Welcome to Real Civil YouTube channel. The purpose of today's video is not to make you aware about the different commands which are related to the loading, how to apply the load. Okay, that is the part and parcel. But in this session, I am going to clear what is exactly a dead load means what for ETAB, what exactly live load for ETAB, floor finish ETAB. Okay, basically I am going to cover the static loads, not only the meaning of the load. I am showing you exactly which IS code we have to refer for the particular load and how to calculate that load. All these things will be cleared in today's session. Okay, so let's begin with the static load. I am not going to cover dynamic loads such as seismic and wind. Okay, so here I have one plan. Okay, so if you see in static load in ETAB, we have to give first dead load, second is the live load, third one is the floor finish, and fourth one sunken area load, and fifth one masonry load. I am going to cover each load one by one. Okay, so first load is dead load. Okay, so let's go in ETAB and create a load case. Okay, define load patterns. Here you have to give the name dead load. Here you have to select the type dead, self-weight multiplier 1, and you have to add. Okay, for this case I will delete this. Okay, now there is a dead load. So what exactly dead load means for ETAB? Okay, so for ETAB, dead load means it consider the self weight. Okay, it consists of self weight of the members, like when you draw the beam, when you draw the column, when you draw the slab. If you have the dead load command, then automatically it calculate the self weight of the member, that is nothing but the self weight of your ultimately the structure. Okay, so here I have given one example how to calculate the self weight of the member. So here we have one beam. The span of the beam is 10 meter, width is 230, and depth is 450. So very simple formula is there for the dead load. So dead load means volume multiplied by density. So here volume means its width multiplied by depth. Okay, and we are calculating per meter. That's why the length we are considering 1 meter, not 10 meter. Okay, into the density of the concrete or RCC is 25. So this is your self weight of the beam, which is 2.5875 kilonewton per meter. Okay, so in ETAB, when you draw these elements like column, I have drawn in 3D, you can see there is a column, slab, beam. So as soon as you draw and the dead load case is activate, then it calculate the self weight, and the logic or the way of calculating the self weight is I have shown here. So this formula is used to calculate the dead load. Okay, and here if you see the dead load self weight multiplier is 1. So here you can check the dead self weight multiplier is 1. Okay, that means it is considering the self weight of the structure. Next, this part is very important. People don't know what exactly the live load in civil engineering. So generally live load means movable loads, something that cannot be fixed at one place. Like human beings, they move from here and there. Okay, furniture, so table is there, beds are there, you can rotate or you can change their position time to time. Okay, like chairs are there, so many things are there. So all these things are considered under the live load category. Okay, so chairs, tables, beds, human beings, all these loads will be considered as a live load. Okay, now if you see, we have to refer IS 875 part 2. Okay, I'm going to show you how exactly look after the loads. Okay, so basically let's open the code first. IS 875 part 2. So this is the code of practice for design loads other than earthquake, IS 875 part 2 1987. So if you scroll down, there is very important table. Table 1 imposed floor loads for different occupancies. Means what? The live load is depend upon the occupancies, right? So here the building I have drawn here is a residential building. So they said that for residential buildings, all the rooms and kitchen, you have to apply a 2 kilonewton per meter square floor load. Toilet, bathroom 2 kilonewton per meter square. Corridors, passages, staircase, you have to apply 3 kilonewton per meter square live load. For balconies, 3 kilonewton per meter square. Similarly, there are different types of buildings are given, like hotel, hostel, boarding houses, lodging houses, okay, residential clubs, garages, educational buildings, institutional buildings, so many things are given. So as per your structure, as per the function of the building, you have to select. Okay, so let's go in ETAB, go to define. We first define the live load case. So just enter live load name, select the type live, and just add new load. Now your live load is added. Okay, now as I told you, my building is residential building. So in residential building, there will be either 2 kilonewton per meter square or 3 kilonewton per meter square load will be there. So from architectural plan, I know that all of these are my like other rooms like kitchen, bedrooms, and this is my staircase. So I will select first the floors. I am not selecting here the staircase because it has 3 kilonewton per meter square load. Others are having 2 kilonewton per meter square load. So this you will come to know from your architectural plan. So just go to assign. Okay, shell load, uniform. Here you have to select the live. As per IS 875 part 2, my load is 2 kilonewton and I will click on apply. Okay. Okay, now here this is my staircase. I know this is from architectural drawing. So I will select this and I will assign a load. Again, shell load, uniform. Make sure it is live load. Now it is 3 kilonewton per meter square. Apply. Okay. Now here you can see the intensity is 3. So it's basically depend upon the occupancy. Now your live load is clear. Now third load is floor finish. So what exactly floor finish means? after we cast the slab, okay, suppose this is my slab, then what we do, we fix the tiles right on the floors, and below the tiles there is a mortar. Okay, so floor finish basically means the flooring load and the cushioning material. Generally this is of sand mortar bed. Okay, so basically it consists of sand, cement and tiles. So all these things will be considered under the title floor finish. Okay, so basically it depends upon which type of tiles you are going to use. Based on the weight of that tile, load will change. Okay, so in practice the engineers either use 1 kilonewton per meter square or 2 kilonewton per meter square floor finish. Okay, so we are going to use a average value which is 1.5 kilonewton per meter square. Okay, now in ETABS you have to create superimposed dead load category. In that you have to apply this floor finish load. Okay, I hope the floor finish is clear. It nothing but weight of sand, cement and tiles. Okay, so first go to load patterns. Here create the case superimposed dead load. Type super dead, add the load, add the new load. Okay, now let's assign the load. So first select all the slabs, go to assign shell loads, uniform. Now make sure here you have SIDL load pattern and 1.5. Apply. Okay, correct. So this is floor finish. Now again there is another load which is applied. That load is called as sunken slab load. Means what? Generally what happens, if you have visited the site, the bathroom or toilet slab is generally lowered. Okay, so suppose this is the floor level. Okay, but due to different attachments related to plumbing, we have to fix the depth of this slab is lowered as compared to regular slab. Okay, you can just search on the Google sunken slab. You will come to know, or different figures, pictures are available. So generally the level of this slab is lowered. Okay, suppose this is my level, then sunken slab level is slightly lower, and then so this is how it looks. So what we do here, we fill this gap by the materials. For that we use different material. Okay, so here I have taken one example. So the depth is 300 of the filling. I want to fill up to 300. Okay, so how to calculate the filler load? So it is a floor load. So we calculate this floor load kilonewton per meter square. Okay, I know the depth is 0.3 and I want to calculate for per meter square. So I have kept here 1 and 1, and the density of the material that you are going to fill. Okay, so here it may be broken bricks, it may be surki, okay, or it may be cinder. So how will you get the densities? For that there is another code of IS 875 part 1 which basically deals with dead load. So if you scroll down, here you will get the unit weights of the different building materials. Okay, so as I told you, I am going to use broken bricks, or in that cinder. So the unit weight of the cinder is 7.85. Similarly, you can check the unit weights of other material also. So here it is 7.85. So I will simply use 7.85 multiply by 1 by 1 means floor area per meter square I want, and 0.3 is the depth of the filling. So I want to fill up to this. So this filling depth is 0.3. So after calculation, it is 2.355. Okay. So total floor finish in the load in toilet area will become 2.355 is my sunken load, 1.5 is my floor finish. So total load becomes 3.855. Because after filling, again I am going to fix the tiles, okay, here, and also I will use the filling material below the tiles. So I have to apply a load of 3.855 kilonewton per meter square. So this is my toilet area. First of all, I will delete this load. Okay. So go to assign uniform. First of all, I will delete the load. Okay, because I want to apply 3.855 load. So select assign shell load uniform SIDL of 3.855. I think 3.855, it is correct. Apply. Okay. Right. So this is how we apply the floor finish. The logic must be clear. So what are the different loads you are going to consider in the floor finish? Next, the last load that we are going to discuss here is masonry wall load. Okay, now this is very clear. Suppose the floor to floor height is 3 meter. Okay, and the depth of the beam is say 0.45, right? So below this area we are going to construct our wall, right? So height of my wall will become 3 meter minus 0.45. That means actual brickwork will be of this length or this height. Okay. Now how to calculate the wall load? I know the thickness of the wall. I know the height of the wall. And I want to calculate this per meter length. So I have considered the length as 1. And this is the density of the material, that is brick. Okay. So you can get this value from IS 875 part 1. As I told you, you will get there is a list of different materials and their unit weights. So bricks are you will get the bricks somewhere, yes, 13 points. So you can see the different ranges of the bricks depending upon the type of brick. So generally we use the value 20. So my wall load become 11.73 kilonewton meter. So this is for external wall, that's why it is 0.23. If it is internal, then the value will change. Okay, so 11.73 is the external. So I will select the external beams. And then I will go to assign frame loads. Now it is a distributed load. Make sure the category is SIDL. Again, we apply the wall load under superimposed dead load category. Mention it in your notes. And it is uniform 111.73. Apply. OK. Now similarly, you can calculate for the internal load of the internal wall, and you can assign it on the internal beams. I hope the loading part is now clear. Okay. I have shown you different types of loads and what is their meaning in ETAB. So this is how you apply the loads, and then you can replicate and you can change depending upon the requirements, like terrace is there, then waterproofing load will be there. Okay, then some reduction in the live load. So all these things you can do, but static loading is up to this. Thank you so much for watching. Please like, share, subscribe. If you have any doubt, you can comment me. I will reply. Thank you so much.